The manufacturing of ballpoint pen tips is a highly precise industrial process because the quality of writing depends on the smooth rotation of a very small metal ball. The process begins with material selection. The outer tip housing is usually made from brass or stainless steel because these metals are easy to machine and resistant to corrosion. The writing ball, however, is made of tungsten carbide, a very hard and wear-resistant compound that ensures the ball will not flatten or scratch during use. The metal for the tip housing is first supplied in the form of long, thin rods or wires. These rods are fed into an automatic cutting machine that cuts them into small cylindrical pieces known as slugs. These slugs are then placed into a cold-forming or cold-heating machine. In this machine, the slug is pressed under high pressure to form the tapered, conical shape of the pen tip. This forming process is done at room temperature, which helps the metal remain strong and dimensionally stable. Once the basic conical shape is prepared, the next step is to create the ink channel and the ball socket. A micro-drilling machine drills a very fine hole through the center of the tip. This hole is extremely small, often less than a millimeter in diameter, and it must be perfectly smooth to allow ink to flow evenly. Inside the tip, a tiny spherical socket is carefully machined. This socket must match the ball diameter precisely. It must hold the ball securely while still allowing it to rotate freely. At the same time, the tungsten carbide balls are manufactured. Tungsten carbide powder is pressed into tiny spherical molds using a binder. These compacted spheres are then sintered at very high temperatures in a furnace. Sintering fuses the particles together into a very hard solid. After sintering, the balls are precisely ground and polished using fine abrasive machinery to achieve a perfectly smooth, uniform surface and an accurate diameter. The typical ball sizes are 0.5 mm, 0.7 mm, 1.0 mm, and sometimes larger for specialty pens. Once both parts are ready, the assembly process begins. A precision assembly machine places each tungsten carbide ball into the socket of the metal tip. The edge of the tip is then crimped or lightly pressed to hold the ball in place. This step must be controlled very carefully. If the crimping is too loose, the ball will fall out. If it is too tight, the ball will not rotate. The correct amount of pressure ensures that the ball rolls smoothly when writing, picking up ink from the reservoir and transferring it evenly onto paper. After assembly, every pen tip undergoes a series of quality control tests. Machines test the free rotation of the ball, check the ink flow passage, and examine the writing performance by making fine test strokes on paper. Any tip that produces uneven ink lines, excessive leakage, or scratchy movement is rejected. Only the tips that pass all tests proceed to final assembly. In the final stage, the completed ballpoint tip is inserted into an ink reservoir tube containing specially formulated ink. The ink tube is then fitted into the outer pen body or barrel, and the pen is completed with its cap, grip, and other external components. The finished result is a writing tool in which the ball acts as a tiny rolling pump, continuously drawing ink from the reservoir and depositing it onto paper in a controlled manner.